So playing around with the practice exam, the module 3 was about understanding what slope means, and this is about graphically looking at slope. And here it says graph any line with a positive slope greater than 1. So I just want to think about that for a second. And I'm just going to take this to draw on. Actually, I really only need that part. Positive slope greater than 1. So positive slopes I talked about the other day and a month or so ago, like m equals 1 is positive, m equals 1/2 is positive, m equals 2. They're all positive. Slope, again, often graphically we look at it as rise over run. So graphically it's nice to have a fraction. And I can turn a number into a fraction, a whole number into a fraction by just dividing by 1. So if I were to graph these, and maybe I'll use some colors too to keep track of them. Let's first get a y-axis and an x-axis. If something is going to have a slope of 1, let's stick with green for this one, then from any point, it would have to go up 1 over 1, up 1 over 1, up 1 over 1. And so head up like that. For a slope of 1/2, oops, wrong color, there we go. Let's do that one in red. From any point, so maybe I pick this point here, that one says to go up 1 but right 2, up 1, right 2, up 1, right 2. And so this would be a set of points with a slope of 1/2. And then the 2 could be written as 2 over 1. Let's try that in blue. Hopefully you can see the difference between blue and green. Maybe I'll start down here. 2 over 1 would be to go up 2, right 1, up 2, right 1, up 2, right 1. So that line, notice it's steeper than the others. So a slope of 1 is a 45-degree angle. If the slope is less than 1 but positive, then it's shallower than 45 degrees. And if it's greater than 1 and positive, it's steeper going up to the right than 45 degrees. So they wanted me to graph anything with a positive slope greater than 1. And so for this problem here, I go back. It's already on the line tool. I can start anywhere I want. And then I want to do better than up 1 over 1. So I just go up 1 over 2 or up 1 over 3. Anything better than up 1 over 1. And so there's tons of different choices. So that one would work here. That's steeper than up 1 over 1. Next one asks me to graph a line with a positive slope that's smaller than 1. So positive, again, is going uphill to the right. I talked about that the other day. So I can't have my line do that or this. That would not be a positive slope. That would be a negative slope. I got to go up and be shallower than 45 degrees. So for example, that would do it. That's heading uphill to the right, so it's positive, and it's shallower than a 45-degree slope. Any line with a slope of -1, I just want to go back and think about what a slope of -1 means. So if m, oops, pen please, if m equals -1, I would view that as -1 over 1. Right? -1 is my rise, which is really a drop, and this would be my run. So from any point, like maybe this one right here, a slope of -1 means to drop 1, go right 1, drop 1, right 1. And so that line would head downhill to the right at a 45-degree angle. And so then I just have to try and do that with this tool. So a line with a slope of -1, so pick any point and then drop down 1, right 1. So that would be that slope there. Let's see if I skipped something. Nope, I got all 3. So greater than 1 positive is rather steep, uphill. Positive smaller than 1 is shallow, uphill to the right. And -1, 45-degree angle, heading down to the right. And so I was just hoping you remembered some of those ideas about slope. Yeah, I got it right. Okay, number 5, I think I wanted to look at next. And this was on, I think, the last lesson in Module 3. There was also a question like this on the last exam. This is about simple interest here. The PRT represents simple interest. So I'm just going to write some things down here. See if I can, oops. My slides got out of order. Oh well. Write these down. So just some reminders about this situation right here. Anytime we use P times R times T, that's simple interest, not compound interest. So we're going to use this formula right here to look at a savings account over time. Sal hopes to have earned $500. Oh, to have, that's future. So right away I'm looking at this and thinking, oh, that 500 is the A, not the P. So he hopes to have that in his savings account in 1 year. Okay, so they're giving me something about T here, and I have an annual interest rate R of 3%. So as a decimal, 3/100. And then fill out the formula with this information right here. So my formula, A equals P plus P times RT. I just need to, it's important I note that the 500 is the A. So 500, I don't know P yet, but I do know R, and I do know T. So I have P times 0.03 times 1. I can clean that up a little bit before I put in there. So I'd probably put it in here as 500 equals P plus P times 0.03. Often we write the number in front, but that doesn't matter too much. So that's okay for this first one. So part A, I think that would be good. Here, how much should he invest now? So that says, hey, what is P? So I have to solve for P here for part B. Problem is there's 2 different P's. And so in order to solve here, we have to do what's called factoring or combining like terms. So I can factor that P out. I'm just going to rewrite this for a sec. Oops. And factoring is like dividing. So what I do is I imagine that I divide each piece here by P, but I pull the P out front with a parentheses. So if I take P and divide by P, I get a 1. And if I take P times 0.03 divided by P, the P's divide out, leaving just the plus 0.03. 1 plus 0.03 adds pretty easy, so now I have 500 equals P times 1.03. And the 1 is 100% of what I started with, and then the 3% increase right here is what I have. And so finally, to solve for P, I can just divide. So P would be the 500 divided by the 1.03, and then we'll check to see if it works. Calculator time. $500 divided by 1.03, and I have to round that a bit, so 485.44, that's what I think it is. So I think that's what I invest now at 3% for 1 year, so I get enough interest so I have $500 in the future. So next I'm going to check this using the original equation. So we always check with the original, not some modified version, because we could have made a mistake anywhere. So check in original. So the original says A, the future amount, is equal to P plus PRT. And so I'm going to plug in my numbers for P, R, and T and hope I get the right A. So then that would give me 485.44 plus that same 485.44 times the 3%, that's a decimal, times the 1. And so next I'm just going to ask my calculator, is this about 500? Now since we did have to round here, it's probably not going to be exactly 500, but it should be pretty darn close. And I could always use the second answer button to do that too. I'm going to first, yeah, I'll use the answer button. So answer is my P plus P again. And on some of your calculators, remember you have to use second to get the answer. And then times 0.03. But look at that, exactly 500. Times 1 is kind of boring. If I had done the approximate version, the 485.44, I'd be close, but not exactly 500. And notice, look, I'm close to 500, just a 3/10 of a cent off. So I'm pretty close there. I could put the times 1 in, but that's not going to change anything. So it checks. That's about 500. So I would invest, or Sal would invest, $485.44, so that he has $500 a year later. So he'll get almost $15 on his 485 over that year at 3%. All right, we're out of time for fun with math today. I do have office hours tomorrow and Friday at 10 o'clock if you have further questions. Otherwise, this is our last official class. Let's stop.